In this video, we are going to continue our discussion 11.5, talking about planes in 3 space. So find the plane. We have this point. So that point is in the plane. Find the plane with the point 221 containing that line. So that means that I'm going to have a plane with a line inside the plane, right? So if I had some kind of 3-dimensional plane, you don't need to copy this. That means there is some kind of line, right, inside my plane. It's like inside of it. Okay, so we have a rough idea of what we have. A couple things that we can grab from L. Let's grab Q, which is the point that's in there. Remember, we gained that from the numbers up top because we're dealing with symmetric equations. So X is 0 because it's minus 0. Then I got a positive 4, and then I got a 0 there too. So I have a Q here. I also have a directional vector from that I'm going to grab. This directional vector is 2, negative 1, 1. Remember, there's nothing over that Z or underneath that Z except for a 1, which would grab that third component. Now, let's keep in mind what we have. Okay, so this vector is inside my plane, right? It's a directional vector for a line. So if the line is inside of my plane, then that vector would lie inside the plane as well, right? It's parallel with any other vector in the plane. I also know that this point is in the plane and this point. Well, if I have a plane, you don't need to copy this again. I'm just going to draw another plane. I have a vector in that plane that's contained. It'd be really nice if I could find another vector in that plane, because I could then find a orthogonal vector that comes out of it, because I could cross this vector with that vector and it would give me an orthogonal vector to both, which would be orthogonal to the plane. And then you may be wondering, like, well, who cares? Why do we need that? Well, remember, we need a point, which we have, right? We have a point, and we need a normal vector. So that's what we are in the search of. So I have one vector. I would really like another vector. Well, we have 2 points. We can find that. So finding that vector, now I have that vector in V1. If I want an orthogonal vector, all I have to do is cross them. So let's put, let's do V first. Really doesn't matter, but my notes go with V, so we'll do that. V crossed with PQ. These are both inside the plane that we're trying to find. So if they're both inside the plane we're trying to find and we cross them, when we cross them, we're going to get an orthogonal vector. So let's do that. Okay, so V is 2, negative 1, 1. The other one is negative 2, 2, 1. Negative 1. Right? Then I use my method here. So I got negative 1, 1, 2, negative 1, I, minus cover that column up. I grab what's in there, 2, negative 2, 1, negative 1. All right. And then this last one, 2, negative 1, negative 2, 2, K. There we go. All right, so we write this down now. Okay, I got, using our diagonal method here, we got 1 minus 2, I, minus negative 2 plus 2, J, plus 4 minus 2, K. So we end up with negative I, 0J, and 2K. All right, so we get negative 1, 0, 2. I like that better. All right, remember, this is our normal vector. And then we also have a point, which we'll use right here. So to write that equation of the plane, it's negative 1, x minus 2, plus 0, y minus 2. You could just leave that off if you want, but I want to do it for note's sake. And then plus 2 times z minus 1. All right, that means we get negative x minus 2 plus 2z minus 1 equals 0. That's standard form. And then we'll go to general form since it's not that far away. Negative x plus 2 plus 2z minus 2. I get negative x plus 2z equals 0. And that's the general form. Alright, so thing that we're looking for often with stuff like this is we are looking for, if I have a plane, what I'm looking for is, one, does it give me a normal vector? And what we're looking at for that is it parallel to another plane, or is it perpendicular to a line given, or something like that? If that's not the case, then what we do is we just make sure we find two vectors inside the plane. Right, find two vectors inside the plane, cross them, that will give you a normal vector once you cross them. Once you cross them, that gives you a normal vector, then you use a point that you have, then you can find the plane. This is going to reoccur a lot. I need you to get in your head that when we cross vectors, it's orthogonal to the beginning vectors.